question with those two projects. But if there is nothing, then we can go and jump in with our agenda today. So I'll go and open the Solana documentation for anyone. So like I said, we are building on Solana. We are trying to see how we can go started, how we can build our first program on Solana. We covered all the basics, starting from Rust. We had Rust, we did all the important stuff that we had to go through. We covered that in our previous days, and to the point where yesterday we wrote our first Solana program. So we are going to build that on top of that. Yes, so for the people that are wondering, Solana uses Rust, and it has a framework called Anchor. That is a really nice framework. It simplifies all the hard stuff. So it is what we are using. Okay, so we have a small playground that we are using. So for the people that are coding with me and you're trying to develop locally, you can go to the beta.sol.pg, and then you can go and create a new project, and then okay, so this is what we had. I'll have to scaffold because this is what I have been testing. So let me go and get the raw one that you guys must be on this same page. So I think it's this repo. I'll copy this just to be on the same page. All right. Yes, so for the people that are starting afresh, maybe let me delete this and we can. So you go to beta.sol.pg, come here, create a new program. Project name, ours is called Heroes. Create that. We have a repo. You can go get the starter code that we have for the people that are starting from scratch. Let me first build this, and after building that, then hopefully I can get this. Okay, so you can get at par with us. Maybe I could change the light theme and zoom in a little bit so that you guys can see what I am writing. Alright, so yes, so yesterday we had our first account. We have the hero account where we want to have program. The program is very simple. We want to create a program whereby a user can submit and create heroes with their hero name, with their age, with their bio, and put them on how many notes. Also, I thought it would be nice if we add an extra field. So because currently these heroes are going to be added by the admin, so maybe we would like to have it. So to do that, I thought of having the author. Maybe we have another field called author, and then whereby we'll have to track the public key. So what the public key is like the address. So I would like to keep track of the person that has created that, and maybe store their public key into this author field. Cool. So the fact that I've added a new field here, this means that the space will not be enough for it to be to be a rent exempt account, so we'll have to update that with the new key that we created. So I'll come back here and maybe create the author. It's called the author length, which is of a U size, and then public keys are of size 32. For the people that are wondering where I've got that, when you go to the Anchor documentation, at the Anchor book, you can scroll down here. There are these references where you can find all the space requirements. So when you look at the public key, it's 32 in bytes. Cool. So it's what we have, and then we can add it to our total space here. So yeah, so now we have the full size of the hero with the author, the person that has added it there. Yes, so adding that there, another thing, like moving forward, we say that everything in Solana is an account. Everything in Solana is an account. Even programs are accounts. The only thing is that programs are marked as executable, whereby they can update state, they can play around with state, they can delete, they can traverse, they can do certain stuff. But they are also programs. Your wallet is not a program because it's not treated as an executable, but it's also an account. So currently we have created an account, but it's not yet executable. So we have to find a way of allowing us to create and extend the blueprint and create and model data using the blueprint of the structure of the hero structure that we have. So maybe we are talking about the CRUD functionality of create, delete, and update, and all of that stuff. So in Solana, you have another function that you have to think about. You have to create a set of two structures, whereby I think of this first structure as the blueprint of what the account has to look like. Then there's another second structure that you have to create, which is going to define the functions that are going to mutate the structure of the account. So let me show you what I'm trying to talk about. So the first function that we know that we want to create is the function that will create the hero, that will add the hero. Maybe when it's passing in the name, the age, the bio, and all its attributes. So the way you can do that, you create a new structure, and then we'll call it create hero, and then add that. So this structure is going to have the blueprints of the function that will communicate with that. So in Anchor, they are what they call attributes. So maybe before we go to attributes, if you notice, we have this public keyword prefixed in at the beginning. The reason why we need this public is because the moment we add this public is we allow Anchor to make this public, these functions and this logic public outside the contract. The moment we don't add this, then it will only be scoped inside the contract. So we want it to be accessible. So you make sure you don't forget to add public here, unless you're creating a private function that will not be accessible. All right, so going back to attributes, these functions, that the behavior functions, and these structures that are going to define the functions, usually Anchor gives you the attributes that are going to give you the boilerplate code. So we have this. So when you come here, you'll find that we have this attribute called derive account. So derive accounts, the moment you add this, Solana out of the box gives you all this functionality without having to write the code. So it gives you the security, it gives you the ownership rules, it gives you all the things that you may need when you're creating your account. So just add this here, If you want to extend and see how it works under the hood, you're always welcome to check the documentation. It's very nice. So when the create hero, after adding the attribute, you are required to add a lifetime. So when you come here, you have to add a lifetime called info. So we didn't cover lifetimes, but basically what lifetimes, they're not specific to Anchor or Solana, but they are specific to Rust. So what lifetime do is just think of them as a way of telling Rust and telling them, hey, this is a variable I've defined and it's going to be alive for up to this time. So you're telling Rust that this variable that I've declared will be valid and it will be alive or will be in life or what for this specific time. So it's like a lifetime of that variable. So it's a generic variable. You can have T, you can have G, you can have P, but the convention is to have it as info in Anchor. It's the common way. So the moment we add that, so everything in this structure is going to be tied to this lifetime. Yes.
If a function is private, do you just leave it, or you can give it there's a keyword that you put before?
No, you can just leave it. When I leave it at that, it stays private.
Okay, thank you.
Yes, but the problem, if you do that, then these other functions will not be able to communicate with it. However much it's in the same script, this other functionality may not be able to communicate with it. So usually you'll have to have something like that.
All right.
Yes. So after having the lifetime, the info lifetime, another step that you'll have to do, remember we are saying that this create hero structure is going to define the mutation, is going to allow us to create this hero. So the first thing that we'll need to have is this hero, the whole hero account placed into the create hero structure. So the way we can do that, we'll give it a field and we'll call it public hero. Remember in Rust, even these attributes must have a public functionality. So if I don't put public here, the structure will be public, but the attributes and the fields will not be public. But remember, I'm going to play around with these fields, and I will have to access them outside the structure itself. So I'll add public there, and I say account. So when I add that account class, I'm telling Anchor that, hey, this hero is going to be of a class account, and it's going to be of the same lifetime as the structure, which is info, and it's going to be of the structure hero. So yes, so I'm telling Anchor that, hey, the hero field is going to be of a type account. It's going to live with the same lifetime. It's going to be of the same lifetime as the whole create hero, and I'm going to access it using this structure. So this is the beauty of Anchor, is that it gives you all this stuff under the scenes that you don't have to think about that. When Anchor was not around, people were writing all this logic from scratch, which was a little bit complex. But just adding this, Anchor out of the box gives you everything that you need with just one single line of code. So we have the hero. And another thing that we'll have to know, we have to like we've pulled the hero, we know that after pulling the hero, we can be able to update the age, we update the buyer, we update the author of the structure. The author, we can't update the author because remember at the author, when we are creating our hero, we'll have to access the public key. So the public key is going to be extracted from the person that creates this account. So if you people have tried to play around with Solidity, you'll understand that there is this message.sender variable. I think it's like that. So this message.sender variable accesses the address of maybe the caller, maybe the deployer, and all of that. So it comes with every function call. So the similar thing will happen in Anchor. For us to get access of the public key, we'll have to extract it from the signer. We'll have to extract it from the person that is communicating with this structure. So the way we can do that, we can get it from the signer. So maybe I can call this my author, and I'll say it is of a type signer, which is coming from Anchor, and I'll give it the same lifetime. And yes, so basically when I do that, this is coming from Anchor. It's going to give me everything that I will need to look for on this variable. So this can be owner, this can be maybe user, all of that. But I like to have stuff all in order, so I'll just give it author as the same name in the hero, so that I know that up on the author I'll have to get the public key. Cool. So this is going to be pre-filled when I call this function, or the user that is going to call this structure. I keep calling it a function, which is not, but eventually we'll transform it into a function. So if I say function, just know we are going to try to create a function that will define that. So the moment we have the author, we are also going to, so Anchor requires you to have another required field, which is called the system program. So this is it's required for you to add it with Anchor. So what the system program does, this field, it allows Anchor to access and do the mutations and all of that stuff. So it has to be there in this structure. So I'll come and I write it's under the programs class with the same lifetime. You guessed it right, and then it is of a system attribute. So basically this is the blueprint of everything that we have. So under the create hero, we are going to pull in the account where we'll create the name. We'll add the age, we'll get the bio, and then we'll extract out the author, and we'll get out their public key, which we'll create here. They created that, we'll see how we get that. So basically this is the blueprints of what we have, but we are not done. So if you remember a few days back, yesterday we were talking about the sizes. We are talking about the sizes of the program. We said that every program in every account in Solana has to pay rent, and for you to make it in rent exempt, you need to give it some money that can take it for 2 years and beyond, so that it can be rent exempt. And the way it can do that is by calculating the size, the total size of that account, and then it will pre-fill the money to pull from the signer, from the person that is communicating, or the deployer, which we calculated properly, but we are not using it anywhere. So when you look at this, when this account is created, Anchor does not know what size it is. It does not know what size it is. So we need to find a way of telling Anchor that, hey, this is creating a hero structure. It's creating a hero account from the hero structure, and it's supposed to be of this size. And after it being of this size, this is the person that is going to pay. So the good thing with Anchor, it has the same attributes. It has a number of attributes that allow you to do that without having to write a lot of code. So cool. So when you come here, you put it above. Remember, we want to find the size of hero, so you put it above this, and then you write a hashtag, and then you write the same account, put in color brackets, and then say init. So we are telling it, hey, this is the initialized account that we want to calculate the size. So, and then another thing we need to tell it, hey, under this account that is getting created, which is the hero, we need to tell it the person who is going to pay for the space. So the way you can do that, you just add the pair field, and we tell it author. So if we had named this another name, maybe if we had named it owner, we had to change it to owner. So keep note of that. So Anchor here will know that, hey, this is the account we are calculating the space for, and the person to pay for it is this. It's the signer. So it will look for that. So the last thing that we have to add is the space. So we tell it the space of the whole thing. So we'll come here, and remember we calculated the space from our implementation on the struct. So we'll come here and write hero, and then the way you can access information out of an implementation, you use the double, is it double semicolon, double quotes? Okay, you use this double stuff, and then we go with the length. So yes, so now Anchor knows the size of the account, which is hero. It knows the person that is going to pay, and it knows the initializing account for that. Cool. So now we are done with that, but we are not quite done yet. So another thing that, remember we said that everything in Solana is a program. Sorry, is an account. And the difference is some are programs, some are just rare accounts. And we said programs are marked as executable. They can change state of the chain. So for you, we've already transformed this into a program, but the problem is that the signer will have to pay for the rent. And the only way the signer will have to pay for rent is by allowing the program to change the balance of money they have in their wallet. So we have to find a way of allowing Anchor or Solana to change the balance, maybe to change the balance in their wallet, so that it can be added to the rent of the program. So currently, remember when we talked about having variables in Rust, that everything in Rust is immutable by default. So currently, this variable is immutable. So Solana cannot change the balance of the signer. So we need to find a way of telling Solana that, hey, this is the signer, and you can always extract money from their account so that they can pay for the rent. So hopefully, and the good thing with Anchor, you do not have to write a lot of code to get with that. There is another attribute. So attributes go above of what you want. So like how we added this on top of the hero, the attribute that we want to add on top of author will affect that. So come down here, you write a hashtag, and then you write account. Inside account function, you write mute. So we are telling it, hey, this is a mutable account. It will change the balance, and it will pay for this rent. Beautiful. So we at that, and our functionality is set at that. We have the create hero. It has the account here. It has the pair, and it has the system program. So please don't forget to add this. You have a question?
Yes.
Yeah.
Like those attributes, are they inbuilt in Anchor, that you just get to know them maybe from the Anchor documentation, or
yes, it is something that is common. I think 90% of the programs you'll find the same attributes. Like, this is one of these things that have been used over and over again, that it has come to the point that you must use it. Like, it's just second nature. So yes, so they give you a lot of boilerplate code. They give you, because for example, you look at this one.
Yes.
Under the hood, it's giving it will give you security feature. It will give you a non-duplicating functionality. Everything is just added for you. So the more you use it, the more you play around with Anchor and building Solana, you always find an attribute that you want. For example, maybe you have a field whereby you want it to trigger another functionality, another structure, and you find that you're about to write a lot of logic to do that. You can always go to the documentation and search for that, and you'll find that there is already another attribute that has been added to to help you with that. So these are things that are always in the documentation, but they are there to help you so that you don't write a lot of boilerplate code.
All right, thank you so much.
Yes, so if we don't have any other question, I think we can move on.
No other question.
Okay, so our create hero structure is done, and now we are going to the other functional part. So currently, so everything has been set. We have the structure to communicate and mutate the account. So we have to find a way of allowing Solana to add these fields. So currently this state is staying as state here. So we need to create functions that are going to communicate and change and do that for us. So the functions that are going to be called, the state changing functions, are described inside this hero mode. And for example, here we had the utilize. Maybe I will go and delete that. So our first function is going to be the create hero. So the naming convention is usually to match this. So for example, in this case, ours will be public fn, and it will be create hero, and then so it is the same name, only that here it is in snake case. So you try to keep it uniform so that your code can be organized and it will be easier for you to debug and to follow up. So like I said, these are the functions. They must be defined inside here. So our first one is create hero. So the first thing that it's going to take in, it's going to take in the context. So this context, this is a context. Everything that you define here is going to be defined as the context. So the convention, if we put it in a ctx variable and we put it in a context, and we'll tell it, hey, the context is we are going to use the create hero. Cool, that is the first variable, and we know that creating the hero will need the hero name, so we pass it there, and it will be of a type string. We know we need the age. I think it's I32. Yes, and we know that we're going to need the bio, which will be of a string. And the other fields, we know how we are going to find a way of extracting the author, and the created that is going to be dynamic. We don't want to create the timestamp from the user. We want to create it, the server want the chain to create it dynamically. So that means we only need the name, the age, and the bio from the function caller. So I don't know if I can collapse that. Yes. So when we have that, we know that this function will have to return something. So I think in the previous versions of Solana, they had this program. I think it was called program, and they'll wrap the result inside here, and then it would look like that. So the good thing in the new updates and the new versions, you don't have to wrap it in a Solana class, in an Anchor class. You can just return the result. So we didn't talk about the result, but result is not specific to Anchor or Solana. It is a Rust. It is tied to Rust. So what it does, it allows you to do error handling. So if you've done something in maybe TypeScript, you remember that you have to find a way of catching errors, and maybe you want to display something when something fails. Maybe you're doing an API call and you want to show some information without having your program to crash. You remember we have something like try, and then you do something like catch, so like that, and then you have the error, and then do something like that. So Rust has something better that is inbuilt. It is this result. What it does is every result, every variable that you have inside, is going to result in two ways. So for example, if you're making an API call and it becomes successful, what result will do, it will return it in an OK format, and it will wrap your result inside here. So it will wrap it here, or it will fail and it will return an error, and it will wrap your error inside here. So this is what result will return. So it is a safe way of logging error messages and caching it, and without having your program to just crash abruptly. So it is the same thing that is going to return here. So, and then Anchor requires you to allow it. So if it is okay and you don't want it to return anything, you can just return okay with an empty string. So maybe we don't have a result here, we just want it to return, so it will just return okay like that. So all if not most of the functions that you're going to write inside here are going to look like this. They're going to return the result, and they're going to have this okay down here. So yeah, take note of that. So okay, I think I can move these comments down here. They are really confusing me. Maybe let me put them here for anyone that wants to read them through, and I'll leave that there. So okay, so we said the first thing that we want to do for this context, so we want to extract these variables from this context. You see, we have to extract these variables from this context. So this is passed directly through using Anchor. So we want to extract that from that account. So the first thing that we want to get is the hero. So we'll put it in a variable. So we write let hero, and it's coming from the ctx.account.hero. So that is the hero. That is the first variable, and you can see Rust is smart enough to show the error type, the attributes and the inference here. So, but remember, when we extract this hero, we are going to change some information. So we are going to mutate it in some way. So and then remember, after mutating it, we are going to use it to do some other stuff. So we do not want to overwrite the parent. We want to just take a reference and mutate that reference. So for the people that were around during ownership, I think you can understand what we are talking about. So we give it the reference, and we are allowed to mutate it there. So we've got the hero. We need to get the author. So the author is also coming from the CTX. So I'll call it author, and we are going to get the mutation, and then so CTX accounts.author. Beautiful. So we have our first two variables, and they are the only ones that we need. So yes, so I know I'm going to have that. I have the hero, I have the author, where I'll get the public key, and another thing that I'll need to have the clock. So what we can use to get the time, we can use clock. So clock is a Rust specific. It's Rust specific. I think it's not from Anchor. So we'll have it in a variable, and maybe we'll call it clock, and then inside clock we'll get clock. So use the clock, and then we go to the get, and then so before I even terminate, you can see, if you guys remember what we are talking about, so you can see that this clock is returning a result. So the moment it returns the clock properly, it's going to be wrapped in this OK, you can see, or it's going to return a program error if it's wrong, if it's not correct. I think it may be tied to Anchor, because I'm seeing a program error here. It could be tied to Anchor, not Rust as specific. So if I try to do this, what if this fails? So the clock the clock variable is not extracted, so it will return the clock if it's created properly, but it will be wrapped inside OK. So the best way, the recommended way to do it is to extract the clock from this. So if you go here, if maybe you read the Rust documentation about error handling, you find that it will tell you to do something like this. So it's clock. Maybe I'll give it, I'll use it in a new variable. Maybe I'll call it final time, and I'll use a match expression. So I'll say match, where I'll pass in the clock, and then so match is similar to the switch case in the other languages like JavaScript. For example, if I have switch, for example, switch, maybe switch name, and then I have case, maybe Peter, and then like something like this, and then I say maybe I'll return, sorry, not range. So return, maybe the name is Peter, like that, and then I think you terminate here, and then I have case, maybe the name is Paul, like that, and then I'll have return, maybe return, the name is Paul, if I can spell the properly, that, and then I have a default like that, and then the default will be not found more, maybe not found here. So this is what switch case in JavaScript or Python would look like. So in Rust it is similar to match. So in this case you don't have to write the case, so you can here write OK, so you get the OK and you extract out the clock, so the clock, and then you return it here, and then we get the error. So I'll give it an error field, and then I tell it, hey, return the error. So whatever is returned from this is going to be added into this closure. So this is what they call a closure. So bash is a closure. What a closure does, it does this computation and it will return the variable, the result, and it will put it inside here. So actually it's not a closure, sorry. Closures are unnamed function. So think of it as this one is returning something. It's going to do this and it will return the clock. So I've destructured the clock outside of here. So you can see it's no longer inside clock. I've pulled it outside of OK, and I'm returning it, and I'm also pulling the error outside of this, and I'm returning the error. So this is the recommended way of handling error management. And if you go to the Rust book, I think it's called the Rust book, and you go to, I think it's error handling, like that. It's a very, very good documentation. You can always look through and see how they can show you how to handle errors and handle panic, like all of that. So yeah, and yeah, so it is the recommended way of doing that, but I don't want to have a lot of code here. So there is another shorthand syntax where you can write unwrap. Unwrap will do whatever this, the way we've done this, unwrap will unwrap it for you, like it will do it under the background. So you won't have to do this, but please try to handle your errors manually so that you can catch all those problems without usually don't lean so much onto this unwrap thing. Usually it's just a shortcut, but we'll try to get it to work here. So so we have the variables that we need. We have the hero, we have the author, we have the clock. So now I think if our data is ready, we can go and start. So we can create the hero. The hero, we have all the variable information we need. So remember, we are changing the fields on this hero. So we come and write hero.name. We set the name that we've entered here from here, and then we go hero.age. We set it there. We have hero.bio. We set the bio there. Cool. So we have hero.author. So author, you can see how the intelligence is spot on. Like, I just press command space and it gives me everything that I need. So author. So we are going to get the public key from this author. So you get that author dot get. I think it's author dot key. Sorry. So author dot key. It extracts out the public key and it adds it there. And then the last thing is hero.created at, which is the timestamp. We are going to extract it from this clock. So clock dot, we're going to use the Unix timestamp variable. So yes, so we have everything that we need. We know that we are creating our hero properly. We have the time and everything is set. Beautiful. So, but we are not yet done yet. We have some issues that we need to address. If you remember, when we are creating space, we added some character limits. For example, on the name, we added character limits on the bio. We don't want them to exceed 240 or 50 characters. Currently, we have no way of protecting that. So if someone maybe injects us with a whole book of characters on the name, there is no way Anchor is going to cache that. It's going to just be put there and it's going to take a lot of space. So they will abuse the chain or the program. So we have to find a way of protecting our program from all those character limits. So I want to do it here before I submit and create the hero. So here I'll have something, maybe I'll have a small padlock here to know that, hey, I'm guard. So I'll say guard from invalid and too long data. Cool. So I'm going to do it before there. And I'm going to use if statement. So in conditionals, Rust has similar conditions with other languages. It's not so complicated. So I'll come and say if name.chars. So name, or it counts every characters. Dot count, and I say if it's greater than 50. If it's greater than 50, I'll say I want to throw an error here. Cool. And also I want to do the same thing for the bio. So if bio.char count, and then if it's 240 or greater, and then I'll tell it to also throw an error. So I want to throw the errors there. So you can write logic here to throw error, maybe print, maybe you format, but Anchor has inbuilt attributes that can allow you to write descriptive error messages to show to your users, to show to your front end, to your clients. So I want to use them here. So I'll come here and maybe I'll put it down here. So I think this is a good time to learn about what enums are. So enums are enumerations. They are, if you've worked with JavaScript, if you've worked with C#, if you've worked with not JavaScript, Python, TypeScript. So if you've worked with TypeScript, C# or Java, you know what enumerations are. They are like named variables where they are tied into one giant object where you can access them. So it's what I want to have. So and I want to use the power of Anchor and these attributes to have custom error messages. Cool. So I'm going to have the first attribute from Anchor. So it's called error code. Add it there, and I have my enum. So my enum is going to be, I'll call it error code.
Excuse me.
Beautiful. Yes.
I would just asking that for you, how do you what do you take as the difference between an enum and a struct? How do you see them different?
A structure has named variables, like it has named variables and types. For example, here name and struct and is a string, age, but enums, it's just variables tied on top of each other. For example, if I have something like maybe I have boy, get a variable called boy, and maybe I'll say boy is empty. Maybe I have let girl. You get, these are unnamed variables. I know Rust will not allow me to do something like this. So instead of having these variables all, I'm defining them over and over again, I can put them together. I can put them together like this, and then have one giant variable to maybe I'll call it people. So I have one giant variable to manage them as they are. So it's basically, it has these variables tied upon each other, whereas a structure is like a blueprint. I think of it as a blueprint of an object. The cool thing with enums, it can also have structures inside here. It is not tied upon just that. It can have structures also here. It can have all kinds of data implemented inside it.
All right, thank you so much.
Yes, so you can see here, so we have the enumeration of, we've called it error code. So I want to use the attributes from Anchor. So they have this attribute called MSG, and what MSG does, it allows you to throw in your custom error messages. So maybe for the name, I want to say name. Maybe I'll say the name must not exceed 50 characters, and then after that I'll give it a custom enum that will call that. I'll say name, maybe I'll call it name too long. So the second one, I'll come for the bio. Remember, we want to also limit the characters for the bio. So I'll call it, maybe I'll say your bio must not exceed 240 characters, like that. So, and then we'll say bio too long. Yes. So we have our enumerations with our custom error messages. So these are coming from Anchor. If I don't add these, it will just throw some error message that is generic. So I want to be explicit, and I've added these custom error messages. So I can use that in my logic here. So remember, I wanted to return an error. So I'll come here and I'll say, okay, return. So I'll say return. Excuse me. So I'll say return. So Anchor has this wrapped error. So remember we said that whatever you can return something using this result. So using the error built on top of this, you can have your custom error messages inside here. So we can call the error that is coming from result. So inside here we know that we have our error code. I think I should have called error code, and then I say my first error code is name too long. So name too long inside the error attribute. So I use the .into field there, and I'll terminate that, and I do the same thing for the bio. So I'll say ER, and I'll call it error code, and I'll call it, maybe let me copy that, make easier for me, put it there and then inject it inside the program is validating, no one is going to name. So yes, so it looks functions, which is create hero, that does that. So this is where you will have to deploy, or you would have to build, maybe you have to test. So the good thing with this playground is it has all these functionalities built there. So if I come here, maybe I want to build and see if I have any issues with my code. So you just press this build and it will build for you. If you have any issues with yours, it will always show you where you've gone wrong. So you can see here we are building successfully, which is a good thing. So so here I would recommend, here is where you start writing your test to test your functions. But I want to first deploy it so that you guys can see how it looks like, what functions are going to be exposed, how are you going to add the create hero, so it gives you a broader picture. So I'll come here. So there is this build button that, so you can see before I deploy. So I already have some Sol here. If you do not have in your wallet, you can go to Solana. You can type Solana faucet. When you go to Solana faucet, there is this airdrop of the devnet. So you paste here your address and you select the amount, and it will be added to your account. So yeah, cool. So our build has been successful. Now we can try to deploy that. So you press deploy, and then it's deploying. If you can see that here, let me try to. So it's telling us, depending on the size, it's, yeah, wait for it to do its magic. Yes, so it has deployed. So let me try to see if I can open SolScan and Solana Explorer to see if everything looks okay. So, this is the payments that we've had for our program. You can see here it's a writable account. It's giving us the source. It's telling us the owner. So if you can look at the transaction, you can see what we've paid for the deployment. So yes, so now the cool thing with this playground is it gives you these buttons where you can play around with it and communicate with that. So you can see even the Solana has reduced because I had some tests to deploy. So the create hero, this is the instructions. So remember we had the instructions. So the instructions are the functions that are going to be changing state. So they are classified under here. And then we have the account. So the account we have currently is the, so if you press all, we have nothing. To create one hero and see how it goes. So maybe our first hero, we are going to call them maybe Batman. We are going to use a custom string. We are going to have the age, maybe he's 45, custom age, and maybe we'll call him the eyes of Gotham City. So have that. So here now we've reached to the account section where so all of this information is coming from this. You get, it's coming from this. So we fill the heroes and all its information. So the moment we added the account and the hero, so Solana is smart enough to go and enter here. It enters here and it pulls all the fields that we need to pass here. So it pulls that there, and it knows from our function we are going to accept the name, the age, and the bio. It adds that there. So, and then it asks us to have an account. So usually what happens here, we are creating a new account. So we want to have a random public key for the account. It's like an ID. We want to have a random IDE. Primary key. For the account. And then the author, we are the author, so we want to come from our current wallet, which is the one here. So, and also the system program. So don't change this one. This one is it has to be pre-filled by Anchor. So I write test, and it has created the function. I hope you can see the speed at which Solana does everything. It's almost as instant. Before even I move my mouse, it has already confirmed. And this is not just on testnet, even on mainnet, it is as fast as you can see here. It's the cool thing about that. So it has confirmed. You can see what has happened. We've called the function. It shows us the program owner. It shows the person, the account. This is the account of the hero. Tells you it is a writable, it has been with the signer, and the signer has paid. Beautiful. So we come back here and let's try to call this and see if we have something. Alright, so we have our user here, we have our first superhero here. Maybe I'll come and play around with that. Maybe I'll come and say, maybe let me add Superman who is 105 years, and then we'll call him, he works at Daily Planet as their bio, and then we want to have a new public key. The current one is coming from us, and then we test. So you're creating a new hero. That one has already come through. Beautiful. So let's fetch and see. And yes, this is Superman. So it comes with this public key. So the public key that we added here to create randomly, it can allow you to search. So let me search for a single field. Maybe I'll come here and press fetch. It will show me all the information I have to have about Superman. So this is as good as it gets. This just adds to the chain. So this is live on Solana. Actually, it's live on Solana, as you guys have seen. It comes with a basic CRUD, but usually what I see is, because this function here comes out of the box when you create your account, maybe we'll have to write our own that maybe with a way it rectifies. Maybe you want to omit some fields. For example, if you have maybe a sensitive field and you don't want it to be fetched, you can create a custom fetch field that omits some of the fields. So yeah, the possibilities are endless. And then I wanted to show you guys how you can deploy that so that you can get the bigger picture. So tomorrow my plan is to, I don't know if it will allow, I was planning to have maybe an update function, and maybe I have to create a new retrieve function, maybe a delete function, and I wanted to do some tests. I don't know what the time will allow us, so that you can see how you can test your functions. So if time allows, tomorrow we'll create a few, maybe we'll complete the basic CRUD and then do some tests. So yeah, I hope I will not have to go through the same things, because we covered a lot today. So most of the stuff here will be repetition, because if you have an update hero, it will look something like this. It will be update hero, and then the accounts and the fields that you're going to set, and then you have another function called update hero, and blah blah blah. So it's going to be the same logic. I think I will go through that very fast, because I want to show you guys how you can test the programs using TypeScript and the front-end stuff. So unless you guys have any questions, then we could see how we do that.
I think we can continue.
Everything good?
Yes, I think we can continue
Yeah.
the testing.
The testing.
Yes.
I want to do the testing. Tomorrow.
Okay.
As the final. As the final piece. I don't know what has happened to my code. I think I pasted in some stuff here.
Okay.
Yes. So my plan is to have the testing final tomorrow as the last piece, because I think this other stuff is just repetition and all of that stuff. So maybe we'll write a test script tomorrow to test maybe this function, and it will be a nice way of closing out.
All right. It's a great journey. This piece, I think, actually, I need always to replay, but it's really great work, quality work. I was surprised at the speed of Solana itself. So
it is a very fast chain, and it's very nice. It has very good developer experience. They have good documentation. They have very good resources. They have a good community. It's something that.
All right. Okay. Thank you so much. I think I don't know if there is anything else.
No, but I think I'll share with the code in the repo. What we've done today is going to be updated in the repo.